Hello everyone. Here we are going to start with exercise 17b of the chapter circles. Here this exercise is based on the chords properties in which the equal chords are equidistant from the center. Now let's do question number 1. Here in question number 1 we are having a concentric circle. Concentric circle means there's two circles or the more than two circles which are having the same center. So here O is the center for both of the circles and there is a common chord, that is AD, which is a chord for the bigger circle as well as for the smaller circle. Now if I draw a perpendicular from here, then this point at which this is going to touch it, that will bisect both of the chord. Either we take AD or we take BC. Now we have to prove this AB equals to CD, that is this portion is equals to this one. तो सबसे पहले हम लोग ये कंस्ट्रक्शन का पार्ट लिखते हैं, that is we have to draw a perpendicular from O to the chord AD. Now after drawing a perpendicular from center O to the chord AD, we'll be getting the point P, and in outer circle AP will be equals to DP as perpendicular from center bisects the chord, and in inner circle also this BP will be equals to CP. So here we get BP equals to CP and the region is perpendicular from center bisects the chord. Now let this one be equation number 1 and this one be equation number 2. Now on subtracting equation number 2 from equation number 1, we get AP minus BP equals to DP minus CP, and here this AP minus BP will be AB and DP minus CP will be CD, hence proved. Now let's move to question number 2. Here in this question we have been given with this figure, और यहाँ पर O और O dash are the centers of the two equal circles. Equal circles means they are having the equal radius, or we can say they are congruent circles. और ये जो M है ये इन दोनों points का midpoint है. This means the line AD is bisecting the line O and O dash, and we have to prove that this line this chord AB is equals to this chord CD. First of all, we are going to draw a perpendicular from here to the chord as P, and from here to the chord CD as Q, and we are going to prove these two triangles congruent, and when we will be able to prove these two triangles congruent, we will be getting this OP equals to O dash Q, and when the perpendicular distance from the center is equal, then these chords are also of equal length. So very first of all, we are going to write the construction. So in construction, we have to draw perpendicular from O and O dash to their respective chords. Now we are going to take the triangle OMP and triangle O dash MQ. Now here we get in triangle OMP and O dash MQ, OM equals to O dash M. So OM is equals to O dash M, as M is midpoint of O and O dash, and here this angle OMP is equals to angle O dash MQ, as these both are vertically opposite angles. Now the last, this angle is equals to this one, as they both are 90 degree each. Now to prove these two triangles congruent, we have used this angle and this side. So it is AAS. Therefore triangle OMP is congruent to triangle O-MQ by AAS congruency criteria, and this side OP will be equals to O-Q by CPCT. And as the perpendicular distance from the center to the chords are equal, therefore the chords are also of equal length. So here we get AB equals to CD, as if the distance of the chord of the equal circles are equal, then the chords are also of equal length, hence proved. Now let's do question number 3. Here we are having this figure in which AB and CD are two equal chords, और M और N इनके midpoints हैं, और ये जो O है ये पूरे circle का center. Now we have to prove this BMN, that is angle found between BM and this one N, is equals to angle DNM. And in the second one we have to prove that AMN, that is this angle, is equals to CNM. Now very first of all, we are going to join this center to the midpoint of this chord, and similarly on this side also. And as we know, the line joining the center to the midpoint of the chord is perpendicular to the chord, so here this will be perpendicular. So as the line joining the center to the midpoint of the chord is perpendicular to the chord, therefore we get OM is perpendicular to AB and ON is perpendicular to CD. Now as equal chords are equidistant from the center, therefore this OM is equals to ON. So here we get OM equals to ON as equal chords are equidistant from center. अब इस triangle में OM ON के बराबर है. So we can take this angle equals to this one. That implies angle OMN equals to angle ONM as angles opposite to equal sides. We know that this angle is equals to this one as this is of 90 degree. So here we get angle OMB, that is this one, equals to angle OND, 90 degree each. Now let this one be equation number 1 and this one be equation number 2. And if I subtract this equation number 1 from equation number 2, we'll be getting angle BMN equals to angle DNM. So on subtracting equation number 1 from equation number 2, we get angle OMB minus angle OMN equals to angle OND minus angle ONM. And here angle OMB minus angle OMN will be equals to angle BMN. So here we get angle BMN equals to similarly over here that DNM. Angle DNM. Now we've got the first part which was to be proved over here. Now we're moving to the second part. Now to apply linear pair property, we are going to subtract both sides from 180 degree. That is, this will be 180 degree minus angle BMN equals to 180 degree minus angle DNM. And on solving this one by using the linear pair property, we get 180 degree minus BMN, that is angle AMN. So angle AMN equals to angle CNM by linear pair property, hence proved. Now let's move to question number 4. Here in this question we are having this figure in which we are having two circles, this one and this one. Here we are having the center O and this one is center O dash. और इन दोनों सर्कल से पास करते हुए एक कॉर्ड है जो कि AB, जो इन दोनों के इंटरसेक्टिंग पॉइंट दैट इज P पे मीट करता है. सिमिलरली एक नीचे से भी कॉर्ड निकल रहा है दैट इज CD, जो दोनों लाइंस दोनों सर्कल से पास करता है और इस इंटरसेक्शन Q पे भी मीट करता है. नाउ वी हैव टू प्रूव दिस O डैश इज हाफ ऑफ दिस AB. तो उसके लिए सबसे पहले वी आर गोइंग टू ड्रॉ अ परपेंडिकुलर लाइन फ्रॉम हियर टू द कॉर्ड्स फ्रॉम द बोथ ऑफ दिस पार्ट्स and let this one be X and this one be Y. So very first of all we'll do the construction by drawing a perpendicular from O and O dash to the chord AP and PB respectively. Now as we know the perpendicular from the center bisects the chord. Therefore this AX is equals to PX as perpendicular from the center bisects the chord. Therefore this can be written as PX equals to half of AP. अब जैसे हमने px को हाफ ऑफ AP शो किया है वैसे ही हम इस वाले सर्कल के लिए py को हाफ ऑफ PB शो कर सकते हैं. So similarly we have got py equals to half of PB. Now this xy will be equals to px plus py, that is equals to 1 upon 2 AP plus 1 upon 2 PB. If we take 1 upon 2 common, then this will be AP plus PB and this is equals to 1 upon 2 AB. Now as we see this line is parallel to this one and this is 90 degree, so this will also be 90 degree and this will also be 90 degree as they are co-interior angles. So using parallel line properties we have got this angle XO dash equals to YO dash O equals to 90 degree. We have used actually co-interior angle property. Now as all of the vertex angle of this quadrilateral is 90 degree, therefore this O dash Y and X is a rectangle and here we get angle O dash YX as rectangle, and we know very well that in rectangle opposite sides are of equal length. So O dash will be equals to XY as opposite sides of rectangle are equal, and here this XY is equals to 1 upon 2 AB. So we can replace O dash equals to 1 upon 2 AB. This was your first part. Now we'll move for the second one. So in second one we have to prove this AB equals to CD. ना जैसे हमने ओ डैश को ए बी की हाफ शो किया है वैसे हम ओ डैश को सी डी के भी हाफ शो कर सकते हैं. So similarly we get o dash equals to half of cd. Now let this one be equation number 1 and this one be equation number 2. So from equation number 1 and 2 we get 1 upon 2 ab equals to 1 upon 2 cd as they both are equals to o dash. Now this half will be cancelled from both of the side and this ab will equals to cd. This is your second part, hence proved. Now let's move to question number 5. Here in this question we are having this figure in which we have to prove this AP equals to CP and DP equals to BP. Now we have been given with the chords equal, that is the length of the chord AB is equals to the chord CD. Now इसको start करने से सबसे पहले we are going to draw a perpendicular from the center to the chord as OX and OY. Now here we have did the construction, the perpendicular from the center to the chord AB and CD, and here we have taken as OX and OY. Now we have been given that AB equals to CD, so AB equals to CD. It is given to us. Now if the whole is equal, then half of them will also be equal. अगर ये पूरे equal है तो इनके आधे भी equal होंगे. Now as this half of AB equals to half of CD, then AX will be equals to CY. As perpendicular from the center bisects the chord, क्योंकि जो center से perpendicular drop करते हैं chord को दो equal part में divide कर देते हैं. तो half of AB will become AX and half of CD will become CY. Now we are going to prove this triangle, that is OYP is congruent to triangle OXP. So here in triangle OYP and triangle OXP we have got angle OYP equals to angle OXP as 90 degree each. Then OY equals to OX as equal chords are equidistant from the center. Then we are having the line OP as common in both of the triangle. Now to prove this triangle, we have used this angle, that is 90 degree, this side that is common to both of it, and this side that is equidistant from the center. So it is R, H and S. Therefore, triangle OYP is congruent to triangle OXP by RHS. Now, as these two triangles are congruent, we can prove this PY equals to PX by CPCT. We have proved this AX equals to CY and we have also proved this PX equals to PY. So let this one be equation number 1 and this one be equation number 2. Now subtracting equation 2 from equation number 1, we get AX minus PX equals to CY minus PY, and this will be equals to AX minus PX, that is AP, and CY minus PY, that is CY minus PY, this will be CP. So here we get the first part of our answer. Now the next one we have to prove this BP equals to DP. We know this AB equals to CD. Therefore now let this one be equation number 3rd and this one be equation number 4. That is, on subtracting equation number 3rd from equation number 4, we get AB minus AP equals to CD minus CP. Now if I subtract AP from this AB, we'll be getting BP, और CD में से CP को subtract करने पे we'll be getting DP. Hence the second part is also proved. That's all for this video. Thank you.